Hi Michelle, how are you? It's Julie Grondin. I figured it might be easier for me to send over a video or two to kind of go through the information that I've prepared, and then you can go through the presentation as well, secondary if you'd like. So I am going to do two videos. One is optional, which is this one. This is to give you some background into the industry that I was working in so that there's some context as to the go-to-market strategy and the messaging and the positioning put out. So this is the first video that gives you some background into the industry to provide more context into the go-to-market strategy, the messaging, all that type of stuff. So I'm going to kick right into this. So Unify, that was the company that I was working with. This is the case study that I'll be talking about. It was a software and services startup company based in Las Vegas. They provided very niche and highly technical solutions for enterprise-level architecture and engineering firms who used Revit, and they practiced something called BIM, which is a concept that I'll explain in a couple slides. The company was engineering-led for 5 years. I was the first full-time marketing hire as a product marketing manager. And there was a lot of work to be done, both in marketing initiatives and just teaching the rest of the company what marketing does, specifically product marketing. So a little bit of a background on what the heck is BIM. Brief history. Prior to 1982, this is how buildings were designed. Guys writing on paper. Predominantly guys, it seems as though. It was very difficult to catch mistakes in design phase, which is what this is referred to as. Charlie over here decided to put all of the doors on his floor at 40 inches wide by accident, while Larry over here used the correct size at 42. So sometimes this wouldn't be caught until people actually came to install the doors, because they had actually gone as far as building the frames of the doors incorrectly on these floors. That's how expensive it can be at the construction stage. It can be really, really, really expensive, these mistakes. And because there's no data, it's paper, there's no reporting capabilities, the only way to see this was to kind of take a look at it and have somebody eyeball and measure each individual thing to see if it was actually working. So now, 1982 rolls around, we have AutoCAD, it hits the market. Most people are familiar with AutoCAD. Instead of drawing lines on paper, you're now drawing lines in a computer. So there's still just lines. There's no data. You could find efficiencies because you could copy and paste these lines and copy and paste portions of buildings and share these files, but there still wasn't any data or real reporting capabilities to identify issues in the model. Now, year 2000, Revit hits the market. Revit is a new design tool. It's kind of like the next phase of Autodesk. The thing is that now when you draw a line in Revit, there's data associated with it. There's spatial data, there's geometry, there's a ton of different things. There's images that you can have in there. There's tons of different data that's associated with these files. And you can have lines, or you can have groupings of lines, or you can actually build out a whole little mini data file of what an air handler or an HVAC system looks like, and save that and use that across all your designs. So you could also commit all of your work to a central design file. So you could have 40 designers working on a model of a building, and then they can commit each of their own unique designs at their desktop level and commit it to a central file, therefore pooling all of the data in one place. So you're able, that's a massive advance, is we have the data and now it's all in one place. And this is what building information modeling kind of is. It is the concept of being able to design with data, having data associated with the design to try to drive efficiencies and have that data follow these designs from the architect and engineering phase over to construction, over to the owners and operators and facilities managers. So we have this building and we know it inside and out with all of this amazing data. Now, the data files that represent these building components, like an air handler, like a window, like a door, it's referred to as BIM content. It's like these little tiny files that you have to build and store or buy, and these are what you now build buildings with. And it allows for that consistency, because when you have a standard door file that everyone is supposed to be using, you share that, and everyone supposedly and hopefully will use that door. So some of the basic challenges in the industry that this actual advancement in technology has now created. Firms are amassing thousands, hundreds of thousands of these pieces of BIM content. There's limited ways on being able to share this, store this, manage, and control it. These are very data-laden files. They can be corrupted. They can become out of date. There's a whole bunch of different things. They're very high-maintenance pieces of content that need very sophisticated ways of managing it. That's one of the products that Unify had, was Unify Core, and that was a library management tool, a BIM content management another challenge was that now that there was all, or basically the issue is that these design models were so data laden, and people could take content from anywhere and stick it in the model. And you really, because Revit didn't have this functionality to kind of detect what was going on, they just had all the data, they didn't have the tools to analyze the data in there. People could stick anything in. You could put wrong BIM in and using the wrong door, but that would make a bad model where you're using the wrong door. But you could also use bad BIM or bad BIM content, and that means that the actual file you just put into your model was corrupt, and now you're going to crash your model and create a whole bunch of different issues that could screw up a lot of stuff and cost a lot of money by crashing the program or corrupting the model. And now you've got a bunch of designers trying to figure out how to fix it, and this can sometimes take days, if not weeks, to fix a crash because nobody knows who did it and what actually went in there. So yeah, that's part of the major issues and stuff that architects and engineers are having in this specific space. So that's kind of an intro. If you're interested in taking a look at that, it will put other things into context, but I'll end this video and then I'll have the second one start up in